Good afternoon, everyone. So, in yesterday's session, we have completed the topic called what is firewall. We had a great discussion on that. We had completed the discussion on stateful inspection and also in the stateless inspection. We have also discussed the Palo Alto firewall history. We have also discussed the PAN-OS, hardware and VM series appliances. So those are the four topics which we have completed yesterday. In today's class, I am targeting my SP3, initial access, and some part of your packet flow. Packet flow is a very big topic. So like for the initial, I will just cover some part of it. Because you are not aware about the Palo Alto configuration and all, right? So you might not able to understand each and every point with regards to the packet flow. So I'll just limit my discussion because once all your topic will complete, I will revisit your Palo Alto topic, this packet flow topic, and where we will discuss everything. Apart from that, you guys have also requested one more topic to discuss, NGFW versus legacy firewalls, right? What is the next generation firewalls and what is legacy firewalls? So what I will do, I'll guys start my discussion with the next generation firewalls and the legacy firewalls. So let me just start from here. Okay, so now let me cover the NGFW versus legacy firewall, because this is the question which is also asked in many interviews, and some of you who is from the routing switching background or don't have a firewall knowledge, might be you will not able to answer properly. Okay, so now let's try to do deep dive into this particular topic. So here what I'll do here, I'll start point by point. Okay, here I will put NGFW or next generation firewalls. So here I will put the list for next generation firewalls. I'll use green color. And here I will basically put the details for legacy firewalls. Okay, now. So guys, first of all, what we have to remember when we are discussing the next generation firewall versus legacy firewall, first point comes like what is the name of firewalls? Which are the next generation firewalls and which are the legacy firewall? So in the next generation firewall list, we have our very first firewall, which is Palo Alto. Second next generation firewall is your FortiGate. Third next generation firewall is your Checkpoint. Fourth next generation firewall is Cisco FTD. Apart from whatever firewalls we are having, I don't consider them as a next generation firewalls. In the legacy list, we have a two very popular firewall. First one is Juniper, SRX, and the second firewall is Cisco ASA. You might know Cisco ASA because this is the firewall. Like around 5 years back, this was the device. So everyone used to start with this particular firewall only. If anyone wants to learn, then he has to start with the Cisco ASA. That was the trend around 5-6 years back. Then We have a sonic wall. Then we have a cyber roam. Fifth, sixth, seven, eight. So we have a Juniper, Cisco SA, Sonic Wall, Cyber Roam. We have a firewall from Barracuda. Okay. We have a firewall from WatchGuard. Then we have a Stone Soft. Okay. Then we have some firewalls from HP, Dell, IBM, EDC. Okay. So those are the legacy firewalls. Now, why those are the legacy firewalls and why those are the next generation firewalls? So now let's try to understand that. So guys, this next generation firewalls, when they will do the packet processing, they used to process the packet on the basis of layer 3 information. At layer 3, they will use source IP, destination IP, and layer 3 protocol number. Those firewalls, they can also able to understand layer 4 information, where they will use the source port and the destination port. Apart from this layer 4 information, those next generation firewall, they can also able to read your layer 7, where we have a data payload. Because those firewalls, they can able to read your data payload from an IP packet. Because those firewalls, they can able to read this layer 7 data, layer 7 information from an IP packet, which is your data payload. So because they can able to read that information, so these particular next generation firewall, they have a feature like app ID, application identification. They have a feature like they will provide the virus protection, spyware protection, vulnerability protection. Then we have a app ID, virus protection, spyware protection, vulnerability protection, URL filtering. Very nice feature, very powerful feature. Then your data filtering. Then they have a one more feature called file protection. Then they have a sandboxing, or with in the firewall terminology, it is known as wildfire. So those are the some feature which is also available in your next generation firewalls. They have those particular feature, and obviously there is a one more, DNS, sinkhole. DNS sinkholing. So DNS is a basically a feature which comes under this spyware protection. Okay. And let me tell you, beneath there is no WEF. WEF is not a firewall functionality. WEF is a totally different device. Okay. Now, see, Because my next generation firewall is able to read this layer 7 information from the packet. So they have a feature like app identification. Means in your next generation firewalls, you are not limited to allow deny the traffic only on the basis of source IP, destination IP, source port, destination port, or layer 3 protocol number. Now you can write the rule simply. Let's suppose you want to allow Zoom traffic. You can just use this application called Zoom. Let's suppose you want to allow Facebook. You can mention just mention Facebook, just allow. Let's suppose you want to allow the Facebook, but you want to block the Facebook chat. That is also you can able to do. Your Facebook application will work, but Facebook chat will be blocked. Let's suppose you want to block the YouTube. In YouTube, you want people can able to stream the YouTube, but they will not able to upload any videos. They will not able to download any videos. So those type of control you will get with this next generation firewall with regards to your application, app identification. Now you are not only limited over the layer 3 information from your IP packet and layer 4 information from your IP packet. What they will do, they will read the content at layer 7. They will read the content at layer 7 and they will try to identify. They will read the data at layer 7 and they will try to identify, oh, this traffic belongs to Zoom. Now, whatever security rule we will configure, like if we have allowed the Zoom, then we can able to simply allow. If we have blocked the Zoom, then simply we can able to block. So that is the very powerful feature. And my Palo Alto Firewall, it supports around 4,700 application. It's a very big number. It has a 4,700 application, which we can include in our security policies. We can able to allow the traffic and we can able to deny the traffic. Guys, in somewhere around in 2000, between 2000 to 2010, when we used to have a Juniper SRX or Cisco SA in most of the organization, how they used to control the traffic? Let's suppose they want to allow the WebEx traffic, or let's suppose they want to block the WebEx traffic or Zoom traffic. What they used to do? They used to request Cisco, because WebEx is owned by the Cisco. They used to request all the IPs which is used by the WebEx. They will request Zoom to share all the IPs which is used by the Zoom. And those IP address they used to basically include in our access list, in our rules, and where they used to put the X and deny. That's how they used to block that traffic. But nowadays, what happening? Guys, if I'll give you the example of torrent. Torrent was the very risky application, and using those legacy firewalls, we cannot able to block the traffic of torrent, because torrent IP address is not fixed. Torrent IP address is not fixed. Torrent port number is also not fixed. Torrent IP address used to change every second, and the port number is also used to change every second. Or let's suppose in your legacy firewall, you have a rule who is allowing the traffic on 443 or on port 80, or let's suppose on port 22. Then torrent can also run on those particular port numbers, and your connection will go through with the ASA. When you will check your ASA or Juniper firewall, you will see there is a communication happening on port number 443 with a web traffic, but in actual, it's a torrent traffic. It's a torrent traffic. What we used to do, guys, apart from that, what I'll do, I will basically connect with the SHS with any server over the internet, and I will create a SHS tunnel. Means inside one connection, I can able to send any type of traffic through this SSL tunnel. I can send the web traffic, I can send the ping traffic, any type of traffic. Those type of tunneling attacks used to happen a lot in the old days when our firewall is not the application aware firewalls. Nowadays, they are the application aware firewalls. They are reading the layer 7 information and they are trying to identify the application, what application we are using. So that type of benefit you will get with your next generation firewall, and that benefit is not available in your legacy firewall. Let me also tell you one more example. Let's take an example for torrent or Yahoo Messenger. Guys, tell me one thing. See, you may ask simply, are layer 3 information not fixed? In case of those application, layer 4 information is also not fixed because they are using dynamically changeable IP address and they are using dynamically changeable port numbers. But how we will make sure that layer 7 information is fixed for them? So tell me one thing, guys, when we will create, like suppose torrent source code or the torrent program, this source code we cannot able to modify, right? Even though if torrent want to bypass those firewalls, right? Then if he can able to change the source code, so torrent cannot able to change source code every minute. So this source code is always fixed. If they did some changes in 2 months, 3 months, 4 months, or 5 months, then those firewall vendors, they used to keep monitoring those type of application, and whatever the additional stuff they have done, they will basically create a similar type of signature. What they will create a same type of signature on the basis of that particular source code of payload. So my firewall can correctly identify, oh, it's a torrent traffic, I should block that traffic. Or if if they have completely changed the source code, then my firewall identify those application as unknown. And what we have to set that action for unknown application, which is deny. We will simply deny the unknown application. So that's how, guys, we will control the access on the basis of application, not only on the basis of your source IP, destination IP, source port, destination port, or layer 3 protocol number. That is the feature of your, that is the feature of your app ID. One more feature I wanted to add here, which is user ID. Now, now guys, mostly for virus protection, for spyware protection, vulnerability protection, if you need a protection from these three, if you need a protection for from virus, from spyware, or from vulnerabilities, then what we used to do, along with those legacy firewall, we used to put one IPS, intrusion prevention system. So you know those virus protection, spyware protection, and vulnerability protection is also known as IPS. Those are the IPS feature. So in with the legacy firewall, we have to purchase a dedicated hardware appliance for IPS, which include the cost. You have to maintain the life cycle of this device. You have to manage the license. You need a one good engineer who can basically make the configuration and troubleshooting on this IPS device. So that solution was a costly solution. But because those next generation firewalls, they have that IPS functionality built in, you just need to purchase the license. In Palo Alto Firewall, if you want to use virus protection, spyware protection, and vulnerability protection, then you need a license of threat prevention. You have to purchase a license of threat prevention. If you have a threat prevention license, you can able to use those three features. Now, what benefit we will get with those three features? Let's take an example here. Let's suppose at your layer 7, whatever payload we are receiving, let's suppose that particular payload has some type of virus, some type of malicious code. It has some type of malicious code. The intention of this malicious code is to just harm your computer. Maybe it will harm your file system. Maybe it will corrupt your operating system files. Maybe it will basically control some of the processes in your system, right? Those are the generally those are the task which those are the intention of any virus. And you know, guys, see, virus when we will try to download any type of file or when we want to access any content, just tell me, guys, if we want to access any content, what are the main protocols we are having? To, we have a FTP, yes or no? FTP we will use for file transfer, yes or no? We have a SMB. SMB is also used for the file transfer. HTTP, HTTPS, those we will use to access the files or any type of content over the web browser. Then we have a SMTP, simple mail transfer, POP3, IMAP. Now tell me one thing. Those particular FTP, SMB, HTTP, HTTPS, SMTP, POP3, IMAP, those particular application works at which layer? Those application works at which layer? So guys, anyone aware about that? At which layer those application used to work? So almost all of you have answered correctly. They are the layer 7 application. Now tell me, is your legacy firewall able to read the layer 7 content? Those legacy firewalls? If they are not able to read your layer 7 data, then do you think they can able to protect your infrastructure from the virus? No, they are not able to do that. Which means, because you know, when those are the layer 7 application and when they will exchange any type of data, that data is also available at layer 7 only. It's a layer 7 payload. Now what we have to do, because my next generation firewall, they are capable of inspecting the information at layer 7 and they will try to identify if there is any type of malicious code is available or any type of virus code is available, because those firewalls, they have a signature database. What? They have a signature database. And if any of the signature will match, then they will basically take the actions right away. They will block that particular traffic right away and they will also generate the log for us, so we can able to also get to know, oh, this is the threat which is detected in our firewall. Now similar thing with the spyware. Do you know what is spyware, guys? Anyone aware about that? What is spyware? What is this spyware? What is the main job of spyware? What is the meaning of spy? What is the meaning of spy? Do you heard the name like spy cameras? India has deployed some spy agents in Pakistan or in other countries, right? Spy means this is a some type of malware. The intention of this malware, when this malware got installed in your system, what it used to do, it used to start spying. Means what it will do, it will start collecting the information. from your PC, it will start collecting some confidential information from your system, and that particular information will try to upload into the hacker server. What it will do? It will try to collect that information like your adware. Adware is a kind of spyware only. Tell me one thing. See, when you used to do a search in Google for flight and all, when you do a search for flight in Google, and after some time, if you will open any other website, you will get lots of suggestion for flights from this particular city to another city. Those, how you will get those particular ads, they are the example of adwares. It is also some type of spyware, because when you have search for a flight, there is a high chance in your system some type of spyware is installed, either in your system, either in a website where you are basically checking that those flights. Might be on that server also some type of spyware got installed, and that is the main reason now they are basically sending some type of ads. Those are the spywares, and you know those spywares is also comes at layer 7 only. What they used to do, they used to collect some necessary information, and they used to share that information with the attackers or hackers system. If we have our Palo Alto Firewall, FortiGate, Checkpoint, or FTD, what they used to do, they used to block such type of traffic right away. What they will do, even though if some type of spyware we have received while accessing anything over the internet, while downloading anything over the internet, what they will do, they will block those type of spywares as well right away. And also if some spyware got installed in your system, and now if that spyware try to send some information from your PC towards the hacker server, then those type of communication is also blocked by the firewall, because they have a DNS sinkhole. So with spyware, you will get the DNS security feature. So DNS security is also configured, because when it will collect the information, and after that he has to establish the communication with the hacker server. So what he has to send the DNS request. And my firewall have those type of details, those type of intelligence. If he will see any type of malicious request going towards the malicious DNS domains, then what it will do? It will block such type of requests right away. So that is the benefit you will get with regards to those spywares. Now we have a vulnerability protection. Not an issue, guys. See all those feature, how virus protection works, spyware works, vulnerability. We will have a great session on that. Don't worry, in future. Now let's try to understand what is vulnerability. What is vulnerability protection? So tell me one thing. Initially, we will be having Windows XP. Then we have a Windows 7. Then we have a Windows 8. Then we have Windows 8.1. Then we have Windows 10. And nowadays we are at Windows 11. Why we have those multiple versions of Windows? Why we are not using just XP? So let me tell you, see, might be you will see some feature enhancement from Windows XP to Windows 7. So what they used to do, what developers used to do, see, might be in Windows XP, there are some feature is missing, or maybe that Windows XP is vulnerable. It has some type of weaknesses, which is known as it has some type of weak point in the source code. And what hacker used to do, they used to exploit those type of weaknesses. What they used to do, they used to exploit those type of weaknesses, and they used to gain the unauthorized access of your Windows machine. So when we will get multiple versions, when we will introduce new features, definitely there are multiple vulnerabilities. There are multiple vulnerabilities is available. And always the intention of the hackers just to break the systems. The main intention of every hacker just to break the system. They always try to find out a way to get the unauthorized access of a system. And how they used to do? They used to they used to do some research and try to identify the weak point at your operating system level, at your application level, or you're at your software level. It's not like that. And also at your hardware level. It's not like that your OS is a weak. If your OS is secure, then you have to make sure whatever softwares you are running, those also secure. And you have to make sure your hardware is also capable enough. Okay. So those type of protection also you will get in your those next generation firewalls, because those vulnerabilities is also a part of layer 7 only. Vulnerability is nothing, it is having some type of exploit, some type of malicious program, that when we will execute those programs into those computers at the OS level or at the application level, what we will do, we will get the unauthorized access of that particular system right away. Maybe we just have a user level access. What we will do, we can do the privilege escalation, and we will become the root on that system, or we will become the administrator on that system. So all those things will happen with the vulnerability protection only. And even though, guys, if you will go and you will search on Google vulnerhub.com, this is the database where you will get multiple machines which are vulnerable for multiple things. You can download those vulnerable machines and you can test your environment. You can download those machines, those are the vulnerable machines, and after that you can start breaking those machines. Okay. So this is a website, like generally for cyber security purpose they used to use that website. And there is a, if you will go for exploit DB, this is the database where you will able to find all type of exploits. Let's take an example. You want to find out the vulnerabilities in Windows 11. Search here Windows 11. Windows 11 has one SMB client privilege escalation and remote code execution vulnerability. This particular version has a elevation of privilege. See, multiple vulnerabilities are there in Windows 11. In Mozilla Firefox, if you are running on Windows 10, full chain client side attack you can able to launch. So this is the database where you will able to find all the vulnerability. Let me type here global protect. In Palo Alto, global protect is also have multiple vulnerabilities like, no, this is not the one. I think I have to search with PanOS. See, Palo Alto Network PanOS, Apache Web3 stack, buffer overflow vulnerabilities is there. Root reboot local privilege escalation vulnerability is there. Even though for all type of Palo Alto vulnerabilities, if you will search into Palo Alto CBE 2025, this is the website. Yeah, security.paloaltonetworks.com. This is the place where you can able to find out all the vulnerabilities which are available in your Palo Alto devices. And guys, all the customers like me, what I used to do, I used to have a look into those pages in the regular basis, and I used to compare my organization devices. Are they vulnerable or not? So we used to get all those advisories every week. We will get those advisory every week, and we have to read those vulnerabilities, and we have to try to identify if that our environment is vulnerable or not for that particular vulnerability. And we have to do some necessary action as well. Like in Global Protect app, it has some type of vulnerabilities, authenticated code injection through the wildcard on Mac OS. Okay. Authenticated admin command injection vulnerability in the management web interface. If your web interface is not secure, then somebody can exploit this vulnerability window. You can able to see this particular vulnerability details. Okay. And if you will just put this particular CB number, copy, exploit DB. So if any type of exploit, you will get a some pre-created exploit as well here. Right now, I think we are not having any exploit with regards to that vulnerability. So you can always try to Google it. CB this exploit. See, you have to read this National Institute of Standard and Technology here. Those are the some websites where they will basically tell you how you can basically, even though in GitHub also you will get lots of like command injection vulnerability in Palo Alto networks. You can read those reference links and you can try to download the exploit and launch the attack. Okay. So you will get those type of exploit and all. So you have to do some research and you can create those particular exploit, and after that you can launch those attacks. So guys, that particular protection is also available in your next generation firewall, which is not available in your legacy firewall. And with legacy firewall you have to use a IPS box. URL filtering, very powerful feature. Guys, tell me one thing, when we will access any website using HTTP or using HTTPS, HTTP and HTTPS protocol works on which layer? Layer 7, which means your URL detail or your domain details available at layer 7. So my next generation firewall can read that layer 7 information. Like from the HTTP get, they will basically analyze this HTTP get packet. They will get the domain name details and they will basically check for the URL, and they will do the necessary action. With HTTPS traffic, they will basically check the SNI field from the client hello packet. It's a first packet in your SSL handshake. If we are not getting the proper detail from the SNI field, then they will check the certificate. In certificate, we have this common name field and we have a send field. From those fields, we will get the URL detail. Now, what is SNI? What is certificate? CN field, send field? We will discuss in your SSL handshake session. Okay, just now. So just remember here, SNI field is a field where if I have visited facebook.com, then I will get facebook.com. This is the field which will hold that particular domain name. Because to do the URL filtering, I need URL detail, right? Without URL detail, I cannot able to do anything. So this URL filtering feature is also available in your next generation firewall. But if you want to configure the URL filtering into that box, then you need a dedicated URL filtering solution. With Cisco, you have to go with the WSA, which is also known as Iron Port, or maybe some other URL filtering solution, other URL filtering device like proxy and all. Then we have a data filtering. So let me tell you guys one thing. See, those particular firewalls, they are not a pure DLP device. They are not a pure DLP device. Okay, they cannot able to provide a pure DLP solution like we have a other DLP solution like your Trend Micro, cloud strike, like those are the pure DLP devices like McAfee, but they also support some type of DLP features. Like if somebody is trying to upload the information of credit card details, or somebody is uploading the details of the Aadhaar card details, PAN card details, passport type of details, and if that details is going through your firewall, then what they used to do, they will basically read that detail at layer 7 and they will block that type of traffic. So that type of DLP also you will get, but it's not a pure DLP. If you want a pure DLP, then you can go for AMP solution, Palo Alto Traps solution, or Cortex XDR. Those are the solutions which is designed for pure DLP. Now we have file protection. We can able to control the downloading and uploading of different file types. Like we can basically, let's say we want to restrict if no one can able to download the .vet file, .exe file, .pdf file, .7zip file. We want to block all those type of zip file, tar file, right? Those type of file protection also we will get with your next generation firewalls. But those feature is not available in your legacy devices. So they don't have, because they are reading layer 7 information. Then sandboxing, very nice feature. What is this sandboxing? So what those next generation firewall they used to do in Palo Alto, sandboxing is known as wildfire. So let's take an example. Let's suppose there is a one hacker community, that is a hacker community. What this community did on 28 June 2025, they have created one brand new malware. They have created one brand new malware. That malware detail is not available with any of those devices in their signature database. They are not having. Now let's suppose now that hacker community flooded this particular malware towards your LAN environment. When your firewall received this particular malware, what it used to do, it will not allow this particular traffic right away. What it used to do, it will stop that particular packet. It will stop this particular packet, and what it will do, it will send this particular packet into one of the machine. Either this machine is hosted into your environment, or either this machine hosted into the OEM environment. What it will send that type of malicious payload into those particular OEM machines over the cloud, and what they will run that particular payload into those machines first, and they will analyze the behavior. What they will do, they will analyze the behavior, because it's a malware, right? So this behavior of this particular payload is malicious. So what they will do right away, they will inform to this firewall it's a malicious traffic, so this firewall will block this traffic right away. And also at the same time, this particular vendor like Palo Alto, what it will create a signature, and it will not only update that signature to this firewall, it will update that signature across all the firewalls which are available globally. It will update that in that particular signature into all the firewalls which are available globally, whether it depends to your organization or some other organization. It will send that signature for everybody. It will basically send that particular, it will send this particular signature into all the firewalls, and that's how they will provide the protection from the newly introduced malware. So they used to mention 0-day protection. Okay. And guys, here we are not discussing license and all. Okay, so you have to stop asking these license related things. We are not discussing the license, we are discussing the feature. If you know the information in advance, then you don't need to write it. Okay, because here I know some of the people, they don't know anything. Here, did I mention anything with regards to the license? So license thing you don't need to ask. In the license class, you can ask those license related question. Okay. We are discussing the feature, and also I'm not limited to discussion with the Palo Alto only. We have these 4 firewalls. Now, DNS sync we have already discussed. Now the user ID. Those next generation firewall, they have a user to IP mapping where we can able to not only we are conveying the rules on the basis of layer 3, layer 4 information or layer 7 information, we will also define the user names, user groups in our security rules, and that type of control we will get. That type of control we will get here. Okay, that is your next generation firewalls. That is known as your next generation firewall. So guys, now what you have to remember from the next generation firewall point of view, you have to know next generation firewall control the traffic, like they can allow or deny the traffic not only on the basis of layer 3, layer 4, they also control the information on the basis of layer 7, because they can able to read the layers of information. So they have a feature like FID, virus protection, spyware protection, vulnerability protection, URL filtering, data filtering, file blocking, sandboxing, or wildfire, DNS sinkholing, user ID. Now guys, starting from virus protection till your DNS security, those feature is also known as content ID. Content identification means you can simply say they have a feature of app identification and they have a feature of content identification. That is your next generation file. Now, in simply, if they will ask the question, if you want to just answer just in one line, you can simply say next generation file will read the information on the base, read the information at layer 3, layer 4, and layer 7, and they can able to we can able to use those layer 3, layer 4, and layer 7 information in our security rules. But our legacy firewall only able to read layer 2 and layer 3 and layer 4 information. They are not able to read the layer 7 information. That's the main difference between your next generation firewall and legacy firewall. Okay. With regards to the sandboxing of wildfire, we have a dedicated class on wildfire, how sandboxing works, what is the exact operations. We will do all such type of discussion. And in the file blocking, we can able to control any type of extension. Okay, I might have some configuration. Let me show you. So let me just give you some idea. In file blocking, if you will see, so we will create those type of file blocking profiles. Okay, now if you will see, it will support 7-zip, bat, CHM, class, CPL, DDL, encrypted zip, EXE, HLP, HTA, jar, OCX, PIF, SCR, tar, torrent, WSF, GIF files, right? And the remaining files I'm just alerting. But it do have other files as well. If I'll go, okay, I will not able to modify this one because it came from the panorama. If I'll go here, let me just first clone. Now if you will see how many file type it used to support, if you will click on it, those are the list. We have a huge long list. It will support those many file types or file extension which we can able to control. So we have a very long list here. Just remember. Okay, so guys, I hope you got the main difference between the next generation firewall and legacy firewall. Ankit, just hold your horse here. Okay, we have a great discussion on the sandboxing in your future classes as well. Okay, and so I'll cover that time because that time I will use some diagrams and all. So I hope Now you have understood this particular difference, next generation firewall versus the legacy firewall. What's the main difference? Everyone is good with that? Even though I don't use to introduce those terms here, but still I have done it. So you will get at least some idea because of this layer 7, we have those many extra features in our device. Those are the extra feature in our device, and that those are the features which makes your firewall as a next generation firewall. Those are the feature which makes your firewalls as a next generation firewall. Okay. Now, just guys, give me 1 second, please. Okay. Now, guys, see, this is also one of the interview questions. So prepare very well. We had a discussion of around 1 hour on the same. Now let me go here and let's try to understand SP3. Now again, SP3 is also a your interview question. This is also a your interview question, and you have to prepare this thing very well. What do you have to prepare this thing very well? So what I can do, let me just start explaining this SP3. So I have this picture. I'll come into this picture in a while. Guys, tell me one thing, if this diagram is visible properly to everyone, this diagram. And also I will introduce one more thing. Guys, do not confuse with that. Those are the some advanced stuff. I know this architecture looks like very difficult, but I am just adding because I want to explain you the SP3. Even though if you will not explain this to anybody, it is also okay because no one is aware about those things. Even though in your interview, if he's not a tech engineers, then he don't know. Okay. I will also use this diagram. Now, let me tell you here. In your Palo Alto firewall, basically, we have a one term called SP3. Palo Alto firewall have a one term called SP3. So how they used to ask this question, they will ask in your interview, can you explain the single pass architecture of Palo Alto? Or can you explain the architecture of the Palo Alto network devices? Or they may ask simply, can you explain what is SP3? So SP3 stand for, we have a starting, we have a 3S, then we have a 3P. The meaning of those 3S is single pass software. Single pass software. Then P means parallel processing hardware. So the meaning of SP3 is single pass software and parallel processing hardware means now here we have to discuss, we are discussing the something regarding the hardware and something regarding the software. What is the operating system at Palo Alto? We have a PAN-OS. Means we are discussing something with regards to the operating system or the PAN-OS. So SP3 stand for single pass software and parallel processing hardware. And we are discussing the Palo Alto hardware as well. Now, in your Palo Alto devices, guys, in your Palo Alto devices, I'm starting with the parallel processing hardware. So in your Palo Alto devices, it has two things. It has a control plane. This is known as management plane. And it has a data plane. So your Palo Alto firewall have two planes. it has a management plane, and it has a dedicated data plane. Now, as name suggests, management plane means it will do some type of management. And data plane is the plane who will basically process the user's traffic, or the traffic which is initiated by your servers or users. Means Palo Alto have a dedicated management plane, which is also known as control plane, and it has a dedicated data plane. Now, what Palo Alto have done? Palo Alto have assigned the dedicated responsibilities or dedicated task to the management plane, and data plane has dedicated tasks to do. Means both of these particular planes, they are aware about what they need to do. They are aware about from the task perspective. And also this management plane, it has a dedicated hardware. Sorry, it has a dedicated CPU, dedicated RAM, and dedicated SSD. Your data plane is also have a dedicated CPU, RAM, and SSD. Now, guys, tell me one thing. To process the data, what we need? We need some type of hardware resources, right? We need CPU. Without CPU, do you think we can able to process anything? We will not able to do, right? So what Palo Alto have done, it has a dedicated management plane, and it has a dedicated data plane. This management plane has majorly three tasks. Configuration management means in your firewall, whenever you will log in through your web browser or through the console cable or through the SSH, for doing any type of configuration, for checking any type of traffic logs, whenever you will basically do all those type of configuration management related task is done by the management plane. Means whenever you want to do any type of configuration changes task done by the management plane. Logging related task is also done by the management plane. Your reporting, when we want to generate any type of report, let's say we want to generate a report for top 10 applications which is visited by my users in last 15 days. Can I have that details? Those type of reports we used to generate, like top 10 IP address who has visited Russia in last 15 days. I want those details. Those type of reports when you will generate, all those tasks is taken care by the management plane. Management plane is having a dedicated CPU. It has a dedicated Intel CPU. It has a dedicated RAM. It has a dedicated SSD. It also have a dedicated management port. This is the OBB port. What is the full form of OBB? OOB? Out of band. Means this is a dedicated port which we are having in your firewall to perform the management plane related task. We will configure the IP address on this management interface, and we will log in into this device through this management port only. It has a dedicated console port. It has a dedicated HA1 port as well. Means if you will see this control plane or this management plane, it has a dedicated resources, yes or no? And it has a dedicated responsibilities as well. Do you see any type of resource level dependency between your management plane and the data plane? There is no resource level dependency. Dedicated resources are there for dedicated tasks. Provides the configuration, logging, and reporting functions on a separate processor, RAM, and hard drive. Now, apart from configuration management, logging, and reporting, this management plane is also responsible for daemon management, like your system daemon, which is a mother daemon of all those daemons. So this is your data plane and this is your management plane. In your management plane, your REST manager, BRD agent, HA agent, FBEP3, where receiver, cryptod, routed, EHMON, sysd agent, F manager, DSCPD, DNS proxy, authd, triple POD, IKE manager, key manager, dagger, SNMPD, SSL manager, log receiver, user ID, management server, and device server. All those particular daemons or processes also a part of your management plane only. All those processes is a part of your management plane only. In data plane, you can see we have couple of daemons like Pentask, TunnelD, sysd agent, master D core. So one core of your master daemon runs in the management plane, one which runs in the data plane. So master D is a main daemon or the father of all those processes. And system daemon is the mother of all those daemons. If those particular process they want to communicate with each other, they used to communicate via sysd only. EHMON, PenDHA, supervisor, BRD agent, MP relay, PANCOM. Those are the daemons. So, whatever daemons I have mentioned here in the management plane, those daemons is also runs in your management plane only. Now, if you don't able to recall these things, that is totally okay. I just wanted to just add here one point. Apart from these three tasks, it is also responsible for PAN, OS, processes, or daemon management. I hope I am clear with this point. So, Umar, you are asking sysd is like a separate chip. We are not discussing chip here. What is the process? I think in like yesterday, I have told you the process. What is the process? It's just a some type of process. In your Windows, there are a hell lot of process used to run in the task manager. It's not any type of hardware. Okay. Now, so guys, I hope you are aware about the functionality of the management plane now. Now we have a data plane. Now we have a data plane. Now guys, what Palo Alto have done? Palo Alto have divided its data plane into three another planes. You can see again the data plane is divided into three another planes. Network processing, security processing, and signature match processing. It has divided its data plane as well. Now each and every data plane, this like signature match processor, it has a dedicated resources for performing the task. Your security processor, it has a dedicated resources for performing the task. And your network processor has a dedicated resource. Resources means RAM, CPU. It has a dedicated RAM, CPU for processing the different tasks. So they are also not having any type of dependency on each other at the resource point of view. They are not having any type of dependency. So do you think they have some type of parallel type of architecture? Like, your management plane able to perform their task at the same time your data plane is performing the other task. They are working parallelly. Yes or no? See, we are making some configuration at the same time your firewall is also processing the packet. So they are doing the parallel task. That is the parallel processing architecture from the management plane and data plane point of view. Now, let's try to deep dive into this particular data plane. Now, I will focus on the data plane because if you know everything with regards to the data plane, then that is very good. So now, if you will see here, now this data plane, they have further divided into three another planes. This is your network processor. Now, this network processor can able to read the layer 2 information, layer 3 information, layer 4 information. That is the three type of information it can able to read, network processor. Your security processor is also able to read layer 2, layer 3 and layer 4 information. And your signature match processor, it can read your layer 7 information. It will read your layer 7 information. Now tell me guys, this app ID or content ID task, where those tasks will be performed by the firewall. It is performed by this plane, networking security, or the content processor or the signature match processor. Those tasks is done by the signature match processor. Now, if you will see, if you noticed here, see those particular processor is also having a dedicated task, yes or no? Right? Now, let me tell you one thing. See, as I have mentioned, your network processor and security processor can able to read layer 2, layer 3, and layer 4 information. Both can able to do. Then why we have a 2 here? Why we are not doing all the tasks here itself? Why we have introduced the network processor? So what you used to do? Let me tell you one thing, guys. See, let's suppose there is a one L3 engineer. There is one L3 engineer. Now, let's suppose this engineer gets some work. And under this L3 engineer, let's suppose there is a one L2 engineer is also there. So, see, it has received some work. Now, this L3 engineer know task 1. Let's suppose those are the two tasks. Task 1 and task 2. Two tasks he has received. Now, this L3 know task 1 is easy, but task 2 is complex. So, what he will do? So, he will decide task 1, sorry, task 2, which is the complex, I will do, and task 1, which is a easy one, my L2 engineer can able to handle. So I will just offload that particular task to L2 engineer. Now, similarly, similar concept or terminology apply to your firewall. What they used to do, because this security processor is the L3 engineer here, the decision maker. This is the L3 engineer, the decision maker. So all your packet processing related tasks comes to the L3 engineer or the security processor. And let's suppose those are the tasks with regards to L2, L3 and L4. Let's suppose those are the tasks which regards to L2, L3 and L4 task only. Means we have to just perform the task on the basis of layer 2 information, layer 3 information and layer 4 information. If this L3 device, this security processor receives some task where if he wants to do the layer 7 processing, then this task it will send to here, right? Just do the layer 7 processing. But let's suppose there are some of the packets on which we don't need to perform the layer 7 task. Let me give you one basic example. Let's suppose we are receiving encrypted traffic. Let's say we are receiving encrypted traffic, and my firewall is not having any type of rule with regards to the SSL decryption. So he is not able to decrypt those particular packets. Do you think those encrypted packet we can forward here? Does it make any sense? No, right? Because that information is encrypted. If I will send that information to the signature match processor or the content match processor, this processor will not help you because it will not able to read. It will not able to read, right? So now, so do you think if there is some traffic where I am not able to read the layer 7 information, so this security processor will inform to your the signature match processor will inform to your security processor, hey, I am not able to read that information because the data is encrypted. Now, if the data is encrypted now on that data, now those are the only tasks we have to perform at layer 2, layer 3, and layer 4. So those type of data, what this security processor will do, like I do have this network processor, it can also able to read those information L2, L3, and 4. So what he will do, he will offload that particular data here. What it will do, it will offload that particular packet here, and he will just inform to network processor, you can start forwarding for those particular packets. Now your network processor will start doing the data forwarding. So means your network processor is also act as a session offloader. It is also act as a session offloader, means whatever session is offloaded by your security processor, those sessions will be processed by the network processor. Now I hope you will understood, guys. For layer 7 we have this. For layer 2, layer 3, and layer 4 we have a security processor and we have a network processor. Network processor will process all the packets which is offloaded by your security processor, means the task which is assigned by this security processor to your network processor, those tasks only it will perform. Like your network processor is a L2 engineer here and your security processor is a L3 engineer here. Now, now one more thing, just remember, see, because those processor, they have a dedicated resources, they are not having any type of resource level dependency. See, when my security processor is doing L2, L3, and L4 task, and this security processor and this signature match processor doing the L7 task, do you think they have any type of dependency on each other at the resource level? Yes or no, guys? Do you think they have any type of dependency? There is no dependency, which means they can able to work parallelly, right? They can able to do the packet processing parallelly. Yes or no? Which means Palo Alto architecture is the parallel processing architecture because of that particular reason. Do you think now it has architecture like a parallel processing hardware? At the hardware level, it used to do the processing parallelly. That is your parallel processing hardware. Now, let me extend my discussion a bit ahead. Now, I will introduce this part. Or before that, let me just introduce this part. Guys, do you remember the first generation firewall? Do you remember the first generation devices from yesterday class? First generation boxes like your PA 200 series box, PA 300 series box, sorry, 2000, 3000, PA 5000 series box. Those are the first generation boxes. Now, in the first generation boxes, now guys, you will get the actual difference. You will also get to know what is the main difference they are having at the generation level. Okay. Now, let me come here. See, in your first generation boxes, this was the data path. Data path means whenever your device receives a traffic, this traffic will go through with this particular data path. Those are the hardware component in your firewall. Those are the hardware component in your firewall. So you know, in your firewalls, all your interfaces, Ethernet 1 by 1, 1 by 2, 1 by 3, 1 by 4, they have a connectivity with one of the chip called Marvel chip. So Marvel chip we will be using to connect all our copper port. Do you know what is copper port? Right? And do you know what is the fiber port? SFP plus ports or SFP ports. So to connect the SFP ports, we have a Petra chip. And those are the hardware basically in your box. So all your interfaces, they have a connectivity with the Marvel chip, either the Petra chip. So your copper ports will have a connectivity with the Marvel chip, and your fiber port will have a connectivity with the Petra chip. Now this particular chip is also known as switch fabric. This chip is also known as switch fabric. Now, just guys, give me a second, please. Now, this particular Marvel chip or the Petra chip, it has a direct connectivity with Liger chip or either the Tiger chip. So in the low end boxes like your PA200 series, sorry, PA2000 series, PA3000 series, we used to have a Liger chip. This is the name of hardware component. And who used to manufacture these chip? Chip is manufactured by the Intel only. They are manufactured by the Intel only. And guys, this is the data plane. This is the data plane. Okay. This is the actual data plane. Now, this Liger chip or either we have a Tiger chip. Now, this particular Liger or Tiger chip is known as a network processor or session offloader. And what type of chip it is? It is a FPGA, Field Programmable Gateway Array. It is a ASIC. Do you know ASIC chips which we used to have in your laptops? Because those are the chip basically which has a powers to perform the different tasks, like they have a RAM and they have a CPU. Okay. Then this network processor has a connectivity with one more chip which is known as Octeon chip. This Octeon chip is also known as data plane CPU. And this is the chip who is going to do the packet processing according to the life of a packet. What are the seven stages we have at in your Palo Alto firewall? Ingress stage, then we have a flow lookup, silo path, fast path, app ID, content ID, and forwarding. Forwarding stage. Those are the 7 packet processing stages in our Palo Alto firewall. Yes or no? So now, this Octeon chip is a main chip. This is a main data plane CPU who used to basically responsible for your ingress stage processing, your flow lookup, your slow path, your fast path, and your forwarding. Your app ID and content ID related tasks done by this particular chip called Jaguar chip, either the Ocelot chip. This is also known as signature match procedure or the pattern match procedure. This is also a FPGA, field programmable gateway array. This is also a FPGA. This is also a FPGA, which is field programmable gateway array. On this FPGA, we have a two type of algorithms, which is DFA and AHO. Those are the two algorithms. Nowadays, there is a one more algorithm, which is PSCAN. Those are the algorithm which is running into this particular chip. And those algorithm will basically do the task of app ID and content ID for you. So now your ingress process stage, flow lookup, slow path, fast path, and forwarding. Those tasks always done by the data plane CPU. And if this data plane CPU is offloaded some of the sessions to this network processor, then your network processor will also able to do ingress stage processing, then fast path and forwarding. Now you may ask why we have not mentioned here flow lookup or slow path. So guys, tell me one thing. Slow path used to happen once, right? Only your first packet will go through with the slow path, and after that, all your remaining subsequent request and reply packet used to go through with the fast path, right? So you know this flow lookup always maintained by the Octeon chip, this data plane CPU. Data plane CPU is responsible for flow lookup. What this data plane CPU used to do, it used to basically get the update regard from this particular Liger or Tiger chip. It used to keeps monitoring here, and it used to just get the data, what type of traffic he is receiving, because the each and every session it has a timer, it has a timeout value. Each session it has a timeout value. Like for TCP, timeout value is 1 hour. For UDP, what is the timer value for UDP guys in Palo Alto? Even though I don't remember, I think it's 30 seconds. And for ICMP, 6 seconds. Those are the timer values, but let's try to check it out here. So let me just show you. So come on. Show session info. So you can see we were TCP default timer is 3600 seconds, which is 1 hour. For UDP, 30 second, and ICMP 6 seconds, right? So you know these session tracking how it used to do, because it is having one edger process, and that process used to run on the data plane CPU only. Okay, so it used to basically track that particular connection details from here. And those are the three tasks basically which is done by the Liger or Tiger chip. Now I hope this task is also clear from the stage point of view. Guys, see, let me tell you, those things nobody is aware about the in the interviews. They will not ask because they don't know. even though they are not expecting those details, but I'm just explaining so you will get some idea. My intention just to give you some idea how firewall component, how Palo Alto component is doing the data forwarding. Okay. Now, so if you will see here, guys, just put your focus. Your data plane CPU is responsible for ingress stage, flow lookup, slow path, fast path, and forwarding, right? Multiple task this particular processor needs to do, yes or no? So let's try to understand the architecture of PA 5000 series box. In Palo Alto 5000 series box, if you will see, we have a switch fabric where we have a Petra chip, which will connect your interfaces. You can see we have a dedicated management plane. I don't call this as a control plane. I always mention this is a management plane. This management plane also have a 4-core Intel. This is just a normal Intel chip, Intel CPU. It has a RAM, dual RAM is there, dual SSD is there. Quad core processor is there from the Intel. Then we have a then we have a network processor where we have a Tiger. Chip name is Tiger. It can do the flow control, route, ARP, MAC lookup, NET, which means almost your L2, L3, and L layer 4 task. Then you can see here now, see the difference. This is your DP, DP0, data plane CPU 0, DP CPU 1, and DP CPU 3, 0, 1, 2. Now in high-end boxes, because in high-end boxes, they are not having single Octeon chip. The security processor, they are not having single processor. They have a 3 chips, 3 data plane CPU, 3 Octeon chip to do the different task. And even though those chip, they have a multiple CPUs. They have a multiple CPUs. At the signature match processor, they are not having just single chip. They have a 2 signature match chips, which is your Jaguar chip. And most of the time they just have a RAM. In signature match processor, most of the time they have a RAM. Some CPU functionality is already there because it's a FPGA, and RAM is there because in this RAM, they needs to store your layer 7 content from the packet to do the analysis. Now here we have a 3 data plane CPU now. Now do you see here? See, let me tell you. Maybe let's suppose I have received 3 packets. Maybe one packet is processed by this engine. Second packet may be processed by this engine, and third packet may be processed by this engine. Let's suppose these are the 3 packets I have received for 3 different sessions. All those 3 packets getting processed parallelly, yes or no? At your security processor level as well. And those processor, do you see any type of resource level dependency? There is no resource level dependency. They can able to handle the traffic independently. They have the dedicated CPU RAM for doing their task. So those particular processor also working in parallel, right? This is the parallel processing hardware. And your actual parallel processing hardware applied for your high-end boxes like PA 5000 series, 7000 series, 5200 series, 5400 series. Those are the actual box which have this kind of architecture. If you will think about the PA 820, This 820 box, it is just having single chip, which is Octeon. All your interfaces, they have a connectivity directly with the Octeon, even though this network processor is not there. Your network processor is also not there in the 820 box. So there is no segregation at the hardware level in 820, but at the software level they have a segregation. At the software level, they have a network processor, they have a security processor, and they have a signature match processor. At the software level also, they used to have a segregation in the low end boxes where they are not having dedicated hardware. Now, apart from this, for some of the complex tasks like your SSL decryption, we have a dedicated chip which is built in with your Octeon chip. This SSL chip will perform the SSL related task. We have a dedicated IPsec chip here, which will perform your IPsec related task. If some type of decompression related task we have to do, then we have a dedicated hardware chip as well at your data plane for performing some complex task with regards to the SSL, with regards to the IPsec, with regards to the decompression. So that is your guys parallel processing architecture of your Palo Alto firewall. See, decompression we need in multiple cases. Let's suppose we have received some type of traffic, some type of files basically which we have to run the unzipping and all, right? For those type of stuff, this decompression engine come in a picture. Now, one more thing I wanted to add here. So your actual parallel processing architecture we have at your 500 series box. Now remember one thing, guys, here. Because see, if you can see here, we have a dedicated DP data plane here, right? And we have a control plane. Now let's suppose we got some issue in your data plane. One of the hardware is not functioning well. At your daemon level or your process level, we have a processes which also runs at your data plane. Maybe some of the processes is not working properly. Then in other devices, what we have to do, we have to simply reboot the entire firewall. But in Palo Alto firewall, you will get a functionality. You can just restart your data plane. You don't need to restart your management plane. That is also one more benefit you will get because of this type of segregation. We can just restart the data plane. We just reboot the data plane. We don't need to reboot our management plane. If there is some issue at your management plane, we can restart a particular process as well. Like your SSH is not working, then we can restart the SSHD. Let's suppose your management, we are not able to take the GUI access of this firewall, then we can start the management server daemon. Let's suppose my firewall is not able to send the logs to the panorama, then we will start the log daemon or log receiver daemon. Those type of benefit we will get because of because due to this type of segregation. Now one more thing, one more benefit we will have because of this architecture. Let's suppose someone has launched the DDoS attack. So generally when somebody will launch the DDoS attack, it will hit your data plane. It will hit your data plane, right? If somebody launched the DOS attack, it will hit your data plane, but your management plane is safe. We can just take the access, we can log in into the firewall through this management plane, and we can do the necessary action, which can protect us from that type of DDoS attack. So that is the benefit we will be getting because of this particular this particular parallel architecture. Now let me again clarify the information. See, generally when we will reboot the firewall, rebooting means we are rebooting management plane and data plane. This is applied for other boxes, but in Palo Alto Firewall, you can just simply reboot your data plane only. You don't need to reboot your management plane. Your firewall is up. You will have the access of your firewall as well, but your data plane just it will restart. And whatever information will be there at data plane, like session, everything will be removed. Obviously, it's a basic stuff. Now, it's the same information, guys. I don't want to discuss this. This is already I have already covered. Now there's a one more thing I wanted to cover here. This architecture you have seen. Now guys, see that is the architecture of your first generation boxes. In your first generation boxes, what we have a network processor, we have a Liger or Tiger chip, we have a data plane CPU where we have Octeon chip, then we have a Jaguar chip, which is for signature match processor. Now, let's try to see the architecture for second generation box. In the second generation boxes, so I have created an architecture for PA 50 to 100 series box. In the latest in the second generation boxes, they have basically replaced the Marvel or Petra chip with the new chip, which is Qumran chip. Now, this particular chip we can use to connect all type of ports, whether it's a copper port or whether it's a fiber port. That is the one of the enhancement they have done. Means all your copper ports and all your fiber ports, they can able to connect with this Qumran chip, which is also a switch fabric. Your Tiger and Liger chip or ASIC or FPG has been replaced with the FE100. FE100 is the new chip which they have introduced in your second generation boxes, which is also known as network processor. This is also FPGA or ASIC. It will act as a session offloader. At the data plane, they will keep the same chip, which is the Octeon chip, but it's a enhanced version of Octeon chip, where we have a DP0, DP1, and DP2. Then your Jaguar or Ocelot chip has been replaced with the C100 chip, which is your signature match processor, or it is also a FPGA or ASIC. So that is the enhancement they have done. Otherwise, packet processing and everything is similar. Packet processing and everything is similar. You may ask, what is this particular? Those particular links is known as joy links. Somebody asks how those chip is connected, interconnected with each other. They have a connectivity with these links. Those are known as joy links. Those are the joy links. And you know, these are the high speed fiber links. Those are the high speed fiber links. So they can able to send the traffic here and there very easily. Okay. So this is the architecture of your second generation boxes. Now you also want to see the architecture for the latest generation boxes, which I don't have, but I can get it from here. PA 5440 architecture, or better I can check for PA 5450 hardware architecture. copy the image, not save. Just I have to click on this one. It's not coming properly. Okay, let me just explain here. So, in this particular architecture, they have a management plane where they have a CPU, but this CPU have a 16 core. See the enhancement. In PA5450, they have a CPU with 16 core. They have a RAM, they have a SSD1 and SSD2, management plane, management port, HA port, and SW-RAD is also they have introduced. Apart from that, in the data plane, they have a network processor, they have a security processor. From this particular chip, what they have done, they have removed the signature match processor. Now this signature match processor task is also performed by this particular chip. Okay. So this is the latest generation boxes. Or might be they have not disclosed the Jaguar chip here or the signature match processor chip as well. Even though I also don't have the access of those type of resources for now. Okay. But let me just see for 7080 architecture. See, because sometime they don't disclose any information, I hear we will not get anything. This is a chassis based device. Okay. Architecture, I think we will not get. Okay. So guys, this is the main difference between first generation boxes, second generation boxes, and third generation boxes. What they used to upgrade their hardware. They used to upgrade their hardware according to the requirements. Now, guys, this parallel processing architecture is clear to all of them. What is this parallel processing architecture? We will all spend almost more than 50 minutes on that. And I guess this is how I can able to explain now. Now let's try to understand now single pass software. What is the single pass software? So first of all, just remember one thing. Your single pass software is applicable only on for content ID. It is applicable only on for the content ID. It is applicable only for your content ID. Where it used to apply? At this stage. Your actual SP3 is applied at content ID stage. Not SP3, your single pass software. Your single pass software applied here at your content ID. Now let's try to understand how it will applied at the content level. So guys, what used to happen? If I'll take example of this chip called C40 or your Jaguar chip or your signature match processor. What used to happen? If you will see, we have a lots of RAM, right? Have you seen, have you noticed we have a lots of RAM at your Jaguar chip? Yes or no? So what used to happen? So let's try to understand. This is the Jaguar chip or signature match processor. This is the signature match processor. Now, guys, tell me one thing, because as I have mentioned, your a single pass software is applied at your content engine at content ID. So at content ID, what are the features we are having? We have a antivirus protection. Yes or no? AB protection is there. Spyware protection is there. Vulnerability protection is there. Like file protection is there. Data protection is there. URL filtering is there. Wildfire is there. Antivirus, spyware, vulnerability, file, data, URL, wildfire, and what others we have? DNS sinkhole. Those are the features we are having here. Now, so what used to happen generally? See, now, as I have mentioned, this CE40 or this signature match procedure, it basically store your layer 7 information, right? Because your data plane CPU, it will hand over the layer 7 information to your signature match processor. So it used to store that information into those memory locations. Those are the memory location where it has stored that information. Okay, that layer 7 information. Let's suppose this is the some layer 7 data it has stored. Now, as I have mentioned, when my firewall wants to do, when my firewall wants to provide the protection, what it used to do, it used to match this layer 7 data against your signature database for different features. Like we have a signature database for virus, for spywares, for vulnerabilities, right? For file, data, DNS sinkhole, wildfire, we have a different type of databases. What it used to do, now data is stored here. Now this data, your antivirus process will pick, process. Your spyware will pick and it will process. Your vulnerability protection will pick and it will process. Your file blocking will pick. Your data filtering will happen. Your URL filtering will happen. Your wildfire checks will happen and your DNS checks will happen. And you know, see, we are storing this information just once here in this particular data. We are just storing this information one time into this memory locations, and all those tasks is done for your on your layer 7 information. All those tasks has been done just in one go. We have to just store that data one time into your signature match processor, and all the layer 7 tasks, all your content ID related tasks will be done, and whatever the output we have received, that output we will update to your DP CPU. And according to The update, let's suppose that particular layer 7 data has some malicious virus over there. Then this data plane CP will take the action because session management done by the DPCP only. And session is the main component. Session will basically, we will change the state of a session, which is discard, which means we are dropping those packets. Because DPCP will take the action. We want to allow the traffic or we want to deny the traffic. So if you will see here, single pass software, do you see some type of single pass software behavior? We are passing this data only one time to your signature match processor and all your content ID task will be done just in single go. Yes or no? And guys, do not do the copy paste the information from Google and all, okay? Because the actual information is not available. Do not search in chat GPT, you will not get that information because it's not there. See here, you have observed the single pass software behavior or not. So this is your single pass software. It applied in your content identification inside your signature match procedure. I hope this is clear now, guys. I hope this concept is clear with everybody. Now let me show you the multi-pass architecture, how the multi-pass architecture looks like. So for that, let me just see where I have the multi-pass. Oh, this is the one right here. So guys, this is the multi-pass architecture which is supported by the other vendor firewalls. I will not name any of the vendor. Okay. Now you can see for URL filtering, for IPS, your packet is repeating every time those particular task. Yes or no? For AB policy, it is repeating those tasks. Yes or no? It's a multi-pass architecture. Why other vendor firewall, they will have a multi-pass architecture? Because they are the UTM box. They are the UTM box. When they have created the operating system, when they have created the OS, what they have done, they have not created this OS from scratch. Let's take an example. Let's suppose we have ASA here. This is the Cisco ASA. For IPS, Cisco basically uses the Snort engine. For proxy, Cisco has WSA. For DLP, Cisco has AMP. For URL filtering, Cisco has WSA. For AB, Cisco has IPS. So what they have done, they have just took the ASA source code, and ASA source code is known as Lena. On top of this source code, they have added the IPS source code. After this IPS source code, on top of this, they have added the WSA source code. On top of this WSA source code, they have added the AMP source code. They have not designed their operating system from scratch. What they are taking, they are just adding extra layer of your source code like this. If they will add the extra source code now, because each source code, it has a dedicated networking stack where they have to basically process your layer 2, layer 3, and layer 4 data each time. So you know your layer 2, layer 3, and layer 4 processing is happening here each time, means all your layer 7 checks with regards to IPS, AB, URL filtering, they are going through with the multiple iterations, right? They are not completing just in one go. Multiple iteration is going on. Because of those multiple iterations, they have a multi-pass type of architecture. Now I receive very nice question from Dipanshu. He's asking how this PA 220 or PA 220R, because they are not having parallel processing hardware or your Palo Alto VM device. How they basically implement this SP3? So see, they are not having segregation at the hardware level, but at the software level they have a segregation, because PanOS software is built from scratch to operate like that only. To operate like that only. Okay. So they have a segregation at the software level, like your content, as I have mentioned, for content ID or your app ID. The algorithm which is AHO, DFA, and PSCAN. Those are the algorithm they will use. Now, what used to happen? Now those algorithms we are running on Oction chip itself. If they have a just single chip, then we are running those chip at the Oction chip itself. And those algorithms are the actual source code, actual software programs who will basically do the single pass software in your Palo Alto device at the content ID level. Okay. So that is your single pass software with some explanation of multi-pass architecture. So I got one question from Raghu. He is asking if we consider only one packet. See, Raghu, I'm not talking about the one packet here. Okay. We are talking about here the proper traffic flow. It's not like the one packet where it will go. Now, multi-pass architecture we have seen. Now firewall initial access.